Dear colleague, I'm Alina Yanko. On behalf of all courses, I want to present a report on this topic, a method of control and operation diagnostics of data errors represented in non-positional number system in residual class. An analysis of existing methods of increasing fault tolerance has shown that the best and most widely used in the practical today are two methods: redundancy and control diagnostic with further restoration of the computer data processing system functionality. When choosing control and diagnostic methods, the main attention should be paid to the ability of these methods to detect errors, as well as the amount of equipment and time spent on control. The principle of control of non-positional code structure are the same as the principle of the control in the positional number system, while taking into account the principle of formation of non-positional number system in residual class and the influence of properties of the system in residual class on the structure of computer system. Let us note the principle of data control in non-positional code structure, principle of reliability of control, principle of continuity of control, and principle of operational control. The concept of development of fast-acting and reliable computer data processing system represent in the system in residual class the urgent task of the development and application of methods and means of operation control and diagnostic of data error. In a computer system operating in the system in residual class, in addition to the main arithmetical operation, addition, abstraction, and multiplication, it is necessary to carry out so-called not modular positional operation. Such operation includes control operation and correction, diagnosis and correction of data errors. Data control, diagnosis, and correction operation compared to arithmetical operation in system in residual class requires significant time for its implementation. The need to implement control operation, diagnostics, and operation of data errors reduce the overall effectiveness of the use of the system in residual class in real-time computer data processing system. The need to ensure the high efficiency of the functioning of the computer data processing system in the system in residual class requires the development and implementation of methods of operation control, diagnostics, and correction of data errors different from the methods used in binary positional number system. The analysis of the research and problem statement determined the purpose of the work, its development and methods for controlling and operational diagnostics, errors in data presented in system in residual class based on the use of the orthogonal basis of partial set of bases. The process of correction of errors in the information code structure of data consists of the following main stage: data control, the process of detecting the presence of errors in the non-positional code structure represented in the system in residual class; data diagnosis, localization of error localization with a given diagnostic depth; error correction in the non-positional code structure, recovery of the distorted residues of the incorrect number, and obtaining the correct number. In order of the non-positional code structure, have necessary corrective abilities, it is required that it contain sufficient information redundancy. To provide data in a non-positional number system in residual class with additional corrective capabilities, only one additional control base with added to the K information bases. In this case, a non-positional code structure is represented by a set of bases in the full working numerical range. Interval is total number of code words for a given system in residual classes with a one control base. For non-positional code structure, minimum code distance depends both on number of control bases and on the size of each of base. Making a decision about correctness of the final result in the carry out according to the simple rules. If obtain number D greater or equal L, this means the resulting number is incorrect. If D less than L, then the conclusion is the number D is correct. In this case, only single errors are assumed, or a packet of errors no more longer than S binary digits of one residue. Data controlling and diagnostic are carried out in two stages. First stage, methods for controlling, monitoring data of non-positional code structure, which from the following algorithm of action determine the value of the orthogonal basis of the complete system of base according Formula 1. Using the system of orthogonal bases, the original number D in the non-positional number system in residual class is represented in positional number system according to the expression 2, and carry out positional comparison operation between the values of D in positional number system and L. If the comparison result shows that D in position number system less than L, the number D is correct. If D in positional number system bigger or equal L, then the number is considered incorrect if only one of the residues of the number D is distorted. Second stage, methods for diagnosing the residues of the code structure of data based on the use of obtained result of the following statement. Let's in ordered non-positional number system in residual class with K information and one control base, the number D satisfies the following condition 3. When condition 3 is satisfied, the residues of the number D are not distorted. If only a single error is not residue is possible, in one residue is possible. The second stage of the developed method will be considered in more details using the specific example. Let's consider an example of using the control and diagnostic method in the non-positional number system in residual class for a 1-byte computer data processing system. In this case, a complete system in residual class is satisfied by 4 information and 1 control basis. At the same time, the requirements for representation of code words in given information numerical range are ensured. Let's calculate total number of code words and total number of information code words in the non-positional number system in residual classes. In this case, the full working numerical range is from 0 to 4620, and information numerical range is from 0 to 420. All possible partial sets of bases of a 1-byte number of 1-byte computer data processing system are represented in table 1. For example, consider the process of finding inversion Li since the complete system of base of considered system in residual class consists of 5 bases, 4 information and 1 control, total 5 bases. The base that is not included in the first line of table 1 is base F I equals 3. So the divide total number of code words L1, which equal is 4,620 to this base 3, or can get the same result by multiplying all set of bases in the first line for table 1. Less in the process of data transmission or processing. Instead, the correct number D, which in a positional number system equal 100, and it's the less that 420, result of operation, a number which is not the same with correct number D. It is necessary to check the correctness of number and diagnose its residues. First stage. First of all, let's determine all the values of orthogonal bases using the formula 1 for complete system of bases, which are presented on this slide. Using the value of orthogonal bases, let's determine the value of obtained number is represented in positional number system according formula 2, which is 3180 in positional number system. Let's compare the obtained number and the value of information numerical range. Since the resulting number is 3180 in positional number system, which is greater than 420, it is concluded that the obtained result is distorted by any one of the residues of the correct number. Second stage. Let's determine the value of the partial orthogonal basis for each of the 5 possible set of the system in residual classes basis. See table 1. In general, the value of partial orthogonal basis is determined based on the following compression 4. So for 4 bases and 5 possible sets of options, we have set of partial orthogonal bases, which are presented on this slide. Let's determine the value of partial orthogonal bases for the first set of bases, I equal 1. It is 4, 5, 7, and 11. See table 1. In this case, inversion L 1 equal 1540, and information numerical range L equal 420. We determine the value for the partial orthogonal basis based on the relationship 4. Determine the value of a partial orthogonal basis B11. In this case, we use a base F1 equal 4. The result of division by expression 4 is 385. We have 3 possible weights of orthogonal bases. Let's compose possible value of B11 depend on the possible weight of orthogonal basis E11, which are presented on this slide. In this case, to fulfill the condition 4, we need to multiply 1 by 385, and we will get the value of B11 equal 385. The same process for B21 and get the result B21 equal 616. This slide shows the process of determining partial orthogonal basis 3, 1 and B4, 1. B31 equal to 1100 and B41 equal to 980. We will calculate all partial orthogonal bases at the same way. The set of the calculated partial orthogonal bases is given in table 2. Second step of the second stage. Let's determine the correctness of the residues of the obtained number. First, let's compose all possible projections of this number, which are presented on this slide. Third step of the second stage. Let's represent the value of the projection in the positional number system, which are presented on this slide. Thus, among all the obtained projection, only the projection 1, 3, and 5 are less than the value L equal 420, and the projection 2 and 4 are greater than 420. The result of controlling and diagnosing the correctness number state of the amount all of 5 residues of the number, it is the residues 1, 3, and 5 may be distorted, but the residues 2 and 5 are not distorted. This paper improves the methods of control and operation diagnostics of data errors represented in non-positional number system in residual class based on the use of orthogonal basis of partial set of basis system in residual class. The value of orthogonal bases are formed from the complete system of bases, and its use makes possible to organize the process of parallel processing of projection number of non-positional code structure. This fact makes it possible to increase the efficiency of controlling and diagnosing data in the computer data processing system operating in non-positional number system in residual class. Example of specific implementation of the process of controlling and diagnostic error are given. It shows that the use of the proposed methods will be improve the efficiency of controlling and diagnosing data errors in the data processing system operating in non-positional number system in residual class, and will also technically simplify the procedure for processing non-positional code structure. Thank you for your attention.